Hi, this is Merlin. Today we're going to talk about the web browser deep dive. And this is part 2. Last video we talked about what is IPC and what is CPU, and like fundamental thing. And we we talk about the how browsers work, like like the process part and rendering part. And we know that there's a lot of process in browser. So in this video we're going to talk about how navigation really works. So what is happening in navigation? So it starts with the browser process. Let's imagine something. You type www.mysite.com and the browser have to see it is valid website. The meaning of the valid website is it is search engine or it is URL. So the browser process, there are a lot of threads in here, and mostly guys thread and network thread sort of storage thread had important role on the navigation part. UIThread is the one who parse it and tells the if if this if this your input is search engine or URL, the URL part, UIThread part, and it also handles the buttons and the address part, and another thread that handles the network stack or receive data from the internet. And the storage thread that controls the access to the file. And first time is handling input. So step one is handling input, and there's a lot of steps. I think there's a step 4 or 5 if you look at the simple navigation. Like I just said, your thread needs to parse and decide whether to send you to a search engine or site that you request. So step 2 is starting on navigation. So the meaning of the starting of the navigation is when user hit enter and your thread need to see it is search engine. What the meaning of the search engine is if you just type ABC. So what we have here, we're gonna go to abc.com. No, you didn't put the com on it, right? You didn't put that com on it. So the Google go to the search part rather than the website. So if you press enter, if it is website, the starting of navigation begins. Loading spinner is displayed on the corner of the tab, and another thread goes to protocol like DNS lookup and establish TLS connection for the request. So what is DNS lookup and TLS connection? First, we're gonna go what is TLS connection. TLS is short term for the transport layer security. It is a protocol that used to secure communication over a network. So example of TLS connection is example HTTPS. HTTPS uses the TLS connection to ensure the client and server is encrypted and secure. First, the handshake. Before beginning, we have to understand what is sync and ACK. So sync, there's a description here. Sync is initial established connection. ACK is they have the confirmation. Sync ACK is kind of receipt. When you buy something, you get a receipt, right? Sync ACK is, oh, I got the connection and I'm ready to keep the connection, and that's and and the state of it. So we begin the connection, and once it received, if it is ensured that communication can be retrieved, it is saying sync ACK, and when it receive ACK, and it's saying if it is sync ACK, oh, we're already ready for the connection. So the handshake begins. This is a handshake, and when you say client hello, the server example or server hello, and the certificate need to be exchanged, the key and value of it. And because of this, this encrypted key value, so you're now ensure that the user is safe, user is trustworthy. And the reason why we have to do this is if we and don't ensure that the client is not trustworthy, that could be cause on some security issue. So we have to ensure the client is trustworthy. So there's authentication. The server usually provides a Discord certificate issued by Trust Certificate Authority. And secure data transmission is once handshake is completed or data transmitted between the browser and server is encrypted, so making difficult to third parties. Third party, because third parties could be a hacker or the one who trying to spread your your website. So what is DNS? So DNS is short for the domain name system. And this part, we're trying to find our website, right? abc.com. We just press it, and what we're gonna happen? We're going to deep dive what we're gonna happen. So abc.com is URL. What is URL? Uniform resource location. We are trying to get the location of abc.com. And if you go to abc.com and it will give HTML and JS and CSS, and render process can render this content and let the user sees after. But the thing is that we have to find the abc.com. The first we have to check if abc.com has the browser has abc.com. This is browser cache, key and value of it. So the reason why we there's a key and value. Not only that, there's a thing abc.com. The domain name is the our abc.com. It needs to be transferred into IP address. So what is address and what is IP? So what IP address is just simple meaning of your location in your network location in this whole internet. And the thing is that the computer cannot read abc.com. Computer could read the number of it, which is IP address. So we have to find IP address that matches abc.com. So we try to see, oh, if there's has abc.com. If there's no, we go DNS resolver. So DNS resolver is the one who resolves this this domain name system and an IP address issue. And this is the one. Uh, the example of it is like phone book. Phone book. If there's like phone book, there's like a lot of phone number, and there's like key the name of it, right? So this rules is to find the IP address. It also has cache here, but if there's and it check abc.com, but if there's no abc.com in the cache, it look at the root server. Once the root server does, it retrieves the authoritative names. It's like high the top of the domain name system, domain name server. Sorry. So it once you ask for it, it gives the TLD, which is stand for top level domain name system. So what is top level of domain name system? The example is .com, .net, or etc. So this is example top level of system. So it's saying that, oh, uh, I don't have your IP address, but we can give TLD. So when you go to TLD, TLD says that, oh, sorry, we don't have your IP address, but we can give b the the .com what is ends with it. So we just said abc.com, so it ends with it .com, and now we see abc.com, and we knew that we have abc.com, and we retrieved the IP address of it, of the DNS system, domain name system, and we already knows that the com exists, .com exists, so domain name system retrieves the real IP address. And once it get IP address of our abc.com, we put it on the cache, and we send it to our browser, and let renders it the website, and then it put the cache on the browser side, so that could eventually you're not gonna go to this complex um, process. We're gonna just use this as we already have cache. We can just get the web page from the web server, and the web server is gonna be this IP address. We just found it, and we put cache on it. And next, so browser thread, no, sorry. So network thread may receive the server redirect header like HTTP 1301. But in that case, so network thread communicates to US thread. The server is request to redirect, and the other URL request to be initiated. So it will just gonna come back of this process. So step three is read responsive. When we got the responsive from the DNS lookup, so this process is called the DNS lookup. Once you get the response, the network thread looks at a few bytes and if the stream is necessary or not. So stream is continuous flow of the data. So we can we can use this stream and check if it's like JPEG file or some kind of file format. And how we do it is we look at the content type header and should say what data type is it. But before that, it could be wrong. So we look at the real code of the payload. So that's called MIME type sniffing. So there's a lot of words. But the summary is the magic numbers. So some file format had unique bytes to sequence at the start. So JPEG start with the bytes is FFF D8 FFF, and browsers know it without looking at the content type header. So at the read response, if the response is a HTML file, the next step would be like passing data to the the render process. So because we have to render it, right? But if it's like J file, so download request could be begin and it go to the download manager. And step four is a find and render process. Once checks are done, the source thread is confident that browser has to do navigate to the request site, and the network thread tells UI thread the data is ready, and UI thread finds the render process to carry render of the web page. So it's just basically saying that network is say it's already ready, and UI thread is trying to ask the render process to begin. So since request could takes like some seconds, some milliseconds, 100 milliseconds, you have to optimize it, right? So it's like mm, rather than waiting for the network thread is done, but we already know the render process know already where to go. is the render process be like standby for the update, but already knows where it's navigating. So step 5 is committing navigating. Now the data is render process is ready, IPC, Internet inter-process communication is sent from the browser progress to the render process to commit the navigation. So it also pass data stream. The render process keep receiving HTML data and or the JavaScript file. So when the browser process hears the confirmation that commit has happened and navigation is completed and the document loading phase begins, and there's could be like the loading on the UI. Once it till the once it when the render process ends and the session history is stored in this disk. This is kind of a big example of it. UI thread tells the render process please render this page. So but what if we just type in like the address bar, input bar, we just type some apes.com. But what if it's like JavaScript? Once you click the button, we could go to another website, right? But in this time, the render process first check before unload handler. It is a kind of event handler, and then it goes through the same process as browser process initiate the navigation. The only difference is the navigation request a kick from the render process or browser process, but this part it is render process. So this kind of also be example of the what if the look the navigation is on the render process. This kind of big example. The two IPs from browser process to the new render process tells the render the page and telling or render process to unload. So how is service worker? We just talk about the how navigation work, but we didn't talk about the how service worker is done working. Service worker is way to write the network proxy in your application code. So it allows the web developer to cache locally when they get new data from the network. And when service worker is set to load the data, the page from the cache, there's no to be new request from the data. So the important part is service worker is done by JavaScript code that runs in the render process. The network thread, once look at the service worker, it is installed or not. And you are trying to find render process to order to execute the service worker code, and that is done. So in case of service worker, we talk about the how it goes. The network thread, rather than making a new request, it just look at the service worker. But if it's already the thread finds the render process to order execute the service worker's code. So the authority is on the UI thread, right? In case of service worker code, in terms of execution. So this is done. And next part, we're gonna go deep about the how HTML and CSS and JavaScript handle or the interact with the rendering process. Thank you.